Alright, 7th grade math. I want to give you guys my version of the explanation for scaling, just so you guys, if you like my explanation or if you like Khan Academy's explanation, you have both ways. So whenever I talk about scale modeling, I like to talk about two things. And one thing is going to be very, very, very useful to us. It's called the ratios. Now, if you remember what we did with the ratios, that was just a fraction that relates to things. Those are any of those fractions we saw before. So we remember we had like x over 5 equals 2 over 3, and we had to cross multiply and divide. So this would be 3x equals 10, and then you divide by 3 on both sides. You found that x is equal to whatever 10 divided by 3 is. That's what we're going to talk about with ratios. We're also going to use a scale is our new definition for today. A scale is just a ratio of a model to a real-life object. Now, because we're doing with a ratio in scales, we can make an equation for ourselves. The equation we're going to be using is the actual number in real life divided by or over the scale number, or what this scale model is going to be equal to. Now, we're going to show you a couple of examples of this. The first one is we're going to find the scale number for this. So it says a scale is equal to 1 centimeter is equal to 5 kilometers. So we're going to do following our equation here. So we know our scale is equal to 1 centimeter, and we are trying to get, in real life world, 5 kilometers. So let's set this up using our equation up here. So now if our scale is equal to 1 centimeter, that's going to go on bottom of our fraction. So we have 1 centimeter. What's our actual number? Well, it's 5 kilometers. So what's our scale number going to be? Well, 5 divided by 1 gives us a scale of 5. Another example of this could be in this case of a map. So we say the scale is 1 centimeter for every 5 kilometers. The actual distance is 14 kilometers. What is the scale distance for the 14 kilometers? Well, we know that we want to set up ours before, so we know we're going to do 5 over 1 again. 5 kilometers over 1 centimeter. Now, they have to always be equal to one another. So it's going to be equal to, what's the actual distance? Well, it's 14 kilometers. And do we know the scale distance this time? Nope. So we can put an X on bottom. So now we cross, multiply. 14 times 1 gives us 14. 5 times x gives us 5x. Now if we divide both sides by 5, we'll get x is equal to what? Give you a second to get out your calculators and figure that out. Okay, you should get 2.8 as your answer. Now there's one more question I want to do for you guys as an example with these. And it is this. It says on a map, 1 centimeter equals 36 meters. If you measured 9 centimeters, how much distance did you travel? So now we can use, again, our scaling equation here. So we know the actual number that we traveled was 36 meters. Well, how many for the scale, how many do we have to go for that? Well, 1 centimeters. So if you measured 9 centimeters, how much distance did you travel? Now following here, where did our centimeters go? On top or bottom? Well, it measured on bottom. It says you measured 9 centimeters. So you put 9 centimeters on bottom and our x on top. Still follow the same exact thing as we did before. We cross multiply. What's 1 times x? Well, that gives you just x. What is 36 times 9? I was just using a calculator for that. 36 times 9 will give you 324. Now, are we done? We sure are, because you went 324 meters. Because if you divide both sides by 1, you have the same exact number there. So this is the introduction to scaling for you guys. We're going to be doing some practice on this tomorrow, as well as drawing scale drawings. And we're going to be applying that knowledge to here. So hopefully you guys found this informational. If you guys want a different explanation or me to answer any questions, please feel free to email me. In any case, thanks a lot for your attention, and hopefully you guys have a great day. Bye.